Okay, so when you have f of x equal to a times sine of kx, or a times, in more general, sine of kx minus x0 plus c, the period is 2 pi over k. The period is 2 pi over k. That means you can write your function in terms of the period as f of x equal to a times sine of 2 pi over t x. Is this clear? Any question? Okay. So question, for example, determine amplitude, maximum, minimum, and the period of a f of x is equal to 5 times sine of x over p plus 2 . Okay, so what is the amplitude? The amplitude is 5. So the amplitude equal to 5. What is the maximum value? 5 plus 2 equal to 7. The minimum value, negative 5 plus 2 is negative 3. What is the period? Two pi . Oh, by the way, let me just change this. My bad. So instead of sine of x over pi, let's say sine of pi x, x times pi. So the period is 2 pi. Here k is pi, so it's divided by pi equal to 2. Okay. I can also give you some question like this, another example. So write a sine function with period equal to for example, pi half maximum equal to 6 and minimum equal to 2. So here, because maximum and minimum are given, that means A, the amplitude is maximum minus minimum divided by 2, which is 6 minus 2 over 2. That is 2. And C is like the center of the oscillation, is maximum plus minimum over 2, the middle of between maximum and minimum. So it's 6 plus 2 over 2, which is 4. How about, so, and the period is given, so T is pi over 2. So now given this, I can say that f of x is a times sine of 2 pi over t x plus c. So f of x is 2 sine of, so t is pi half. So 2 pi over pi half is 4. Is this clear? No, I'm teaching now. Is this clear? Or anything? Okay, so remember that we have, if you have sine of kx, period is 2 pi over k. Period is 2 pi over k. That means, equivalently, k is 2 pi over t, right? So if the period is given, that means f of x is a times sine of 2 pi over tx, and then plus c, and whatever. So it follows from this equation. I can write here, t is 2 pi over k, so therefore, k is 2 pi over t. Okay. So now let me do some more. Maybe we can look at the assignments that I gave you. Okay, you all have this assignment, right? Do you see my screen? On the first page, do you have any question? Any question on the first page? No? Do you know how to do 4? 3 or 4? Yeah? So remember that. Let me just recall. If you have piece of a circle, which is called an arc length, So this, if this is theta and the radius is r, then the arc length, this is the arc length. Let's say S, the arc length is just, what is the formula? You remember? R times theta. But theta here is in terms of radians. So theta is radians. Okay, so no question in the first page? Second page? So the only thing in this page that I didn't mention is the function tangent x. So the function tangent x is a very interesting function. Maybe it's good to talk about it a little bit. So I want to look at the tangent function. So it has many vertical asymptotes, infinitely many. And I tell you why. So first, let me just draw the graph of tangent. So this is the graph. So what is the tangent? So this is y equal to tangent x. What is the definition of the tangent? So f of x equal to tangent x. We know that tangent x is equal to sine x over cosine x, right? So that means when the denominator approaches 0, the entire thing goes to infinity. When the denominator, which is cosine, approaches 0, tangent goes to infinity. So at what points, for what values of x, cosine is 0? Yes. Pi over 2, and then 3 pi over 2. Oh, sorry, this is pi over 2. 3 pi over 2, minus pi over 2, and so on. Minus 3 pi over 2. So there are infinitely many points for which cosine is 0. So that means at this point, you have vertical asymptotes of tangent. Is that clear? Now, for example, when x goes to pi half from the left side, so from the left side, I mean here, from this direction, then sine is positive. Cosine is also positive. So it goes to positive infinity. But once you pass the pi half, so when you go approach pi half from the right side, that means here, because sine is cosine negative, then the whole thing becomes negative. I mean, in general, tangent is negative in the second quadrant, right? So it goes to the negative infinity, and so on. So for tangent, you have infinitely many vertical asymptotes. So you have the vertical asymptotes of tangent at x equal to pi half, 3 pi half, and so on. Also negative pi half, negative 3 pi half, and so on. So these are the vertical asymptotes of tangent. So maybe I just can write the vertical asymptote are plus minus pi half, plus minus 3 pi half, plus minus 5 pi half, and so on. So that means, so here, what is the range of tangent? What are the possible y values for tangent? Look at the graph. Is everything. So because it covers all the y values. So that means range of tangent. So its range is equal to all real numbers. But its domain is all real numbers except this vertical asymptotes. So everything except this vertical asymptote is the domain. Is that clear? Okay, now you can do the same analysis for cotangent, but cotangent goes to infinity. So because cotangent is the flipping, tangent flipped. So cotangent is cosine over sine, right? So cotangent goes to infinity when sine goes to 0. That means cotangent goes to infinity when x is 0, pi, 2 pi, and so on. Okay, now let's go back to these questions. That's a good question. You can do it by tomorrow. So it's until question 22, from 1 to 22. I mean, you don't need to do this test. I mean, you can look at the questions, there are good questions, but you don't have to submit as your assignment. Okay? So only from question 1 to 22. Okay, now let's go back to the questions. Do you have anything, any question on the second page? No question? Nothing, Alex? Which one? Oh, what is the y-intercept? Y-intercept means when x is 0, what is the value of y? So when x is 0, so y-intercept, that means let x is 0, then what is y? Is 0. So the y-intercept is 0. Okay, now next page. Now it says, what are the x-intercept? Question 13. So here is a there are some points here. What are the x-intercepts or zeros or the roots when x is between minus 2 pi to 2 pi? So here you have to look at this interval. What are the zeros of cosine when x is between minus 2 pi and 2 pi? Can you tell me, Maggie? Yes, exactly. So you have to look at the roots between minus 2 pi and 2. One is pi over 2. Yeah. And then 3 pi over 2. And then minus pi over 2. Exactly. So you have to look at this specific interval, minus 2 pi to pi. Question 14 is quite similar. It says that for what values of x, cosine is equal to 1 when x is between 2 pi, minus 2 pi to 2 pi. So cosine equal to 1. So in general, when you say cosine equal to 1, in general, cosine x equal to 1, that means x is equal to what? It's just 2k times pi for any integer, right? 0, 2 pi, 4 pi, minus 2 pi, and so on. Now, which one is between minus 2 pi and 2 pi? And here, it doesn't include minus 2 pi and 2 pi. The only thing is 0. So in this specific interval, when x is between minus 2 pi, 2 pi, exclusive, it doesn't include minus 2 pi and 2 pi. So the only thing is only x equal to 0. I mean, in this interval. Question 16. And question 15 is not bad. You just have to draw the graph. 16, amplitude, period. What is the period? First of all, remember that cosine is an even function, right? This is another important point. So cosine of minus x is equal to cosine of x. So that means here, 2 times cosine of minus 6x is equal to, this equals 2 times cosine of 6x. Okay? Because cosine of minus x is equals to cosine x. Now, what is the period here? Two pi over 6, right? Which is pi over 3. Question 17, something that I just did today. It says that the amplitude is 5 over 4, period is 6. So can you now tell me what is the cosine function? Amplitude is 5 over 4. Period is 6. So you have cosine of what? Yes, which is 2 pi over 6 x, but 2 pi over 6 is For question 18, so in order to find the period is basically the distance between any two peaks or the distance between the two consecutive minimum or two consecutive maximum. So here, to find the period, you have to find the distance between the two minimums. I mean, you can either find the distance here. You can also look at this distance. I mean, these are the same. So it's easy to compute the green, the distance, right? This gives you the period. For computing the amplitude, is just the difference between maximum point, minimum point divided by 2. So here maximum is 4, minimum is -4. So the amplitude is 4 minus -4 divided by 2 is just 4. Right? Is that clear? Now, can you tell me what is the period of this function from the picture? Liana, can you tell me? Pi over 2. You see this green, this green distance is pi over 2, right? Now, first, period is pi over 2, right? I mean, this is from the picture. There's no K and nothing in the picture. I mean, the period means basically when you have, let me, here is like you have any oscillating like sine or cosine or whatever. So the period is the length that this guy is going to repeat itself. See? So you can either look at this length, or it's the same as this length, or the same as this two. But I mean, here the period is either this length, or you can look at these two things, or this. So basically, the distance between two consecutive points on the graph. But in this picture, it's clear it's pi over 2. But in your equation, when you want to write the cosine, once you have the period, is f of x equal to a times amplitude cosine of 2 pi over t times x. So if you find t, you plug it into this formula, then you find the equation for cosine. Clear? This page? Next page? No question? I mean, so it's enough if you do until question 22, but on this page, there are good questions, especially for the identities. It's a good practice if you do, for example, question 2 or question 1 even. these are good practice for proving identities. Let me do some of them for you. So let me see. I want to do question 7 on this page. So it says that prove that tangent theta is 1 minus cosine 2 theta, this question, divided by sine 2 theta. So as I said, when you want to prove some identity, you have to begin with one side and you reach to the other side. So here I begin with the right-hand side. So the right-hand side is 1 minus cosine. So the question is prove the identity. 1 minus cosine 2 theta over sine 2 theta is equal. So what is cosine of 2 theta? Remember that cosine of 2 theta is, remember that I told you yesterday, let me write it here. So cosine of 2 theta is equal to cos square theta minus sine square theta which is equal to 2 times cos square theta minus 1 and is equal to 1 minus 2 times sine square theta. Okay, so we have this equations, this relation for cosine of 2 theta. Now, 1 minus cosine of 2 theta, if you use the last line, so cosine of 2 theta is 1 minus 2 times sine square. So this becomes so if you use this very last line for cosine of 2 theta, if you plug it in, you get equal to 1 minus 2 sine square theta divided by sine 2 theta. And also remember that sine 2 theta is 2 times sine theta times cosine theta. So on the top, 1 minus 2 sine square is just 2 sine square divided by 2 sine theta cosine theta, which is equal to 2 sine theta over, the two also cancel out each other. So you get sine theta divided by cosine theta, which is equal to tangent theta. Now that is just the left-hand side, right? Is this clear? This proof? Liana? Is that clear? So another type of questions that one can ask is like solving quadratic equations. Like for example, question 11, 10, 11, or even 8 and 9. So do you know how to do 8, 9, 10, 11, 12? This one? So here I'm using this equations for cosine of 2 theta and sine of 2 theta. So cosine of 2 theta is equal to cos squared theta minus sine squared theta.
Wouldn't it be like negative to sine squared?
Which one?
So this part to
So
that part
you
would
look,
be
1 minus 1 is just 0, but you have negative 2 is 2. Negative, right?
Oh, you don't multiply like I did.
Yes.
1 multiplied to negative 1 is negative.
No, this is 1 minus. You see, this is minus. There's no here. Let me do nine, for example, and 10 on this page. So question 9, it says that you have to solve this equation. First, assume that theta is between 0 and 2 pi. Then you can assume that over the real numbers. So theta can be anything. So I will do first I will do the second part. It's easier. So you have 3 times tangent theta equal to minus root 3. So tangent theta is minus root 3 over 3. So now, for what angle between 0 and 2 pi, tangent is minus root 3 over 3? For what angle tangent is minus root 3 over 3? You remember? So it's either pi over 3 or pi over 6. But which one? I mean pi minus pi over 6 or pi minus pi over 3. What is theta? If tangent is minus root 3 over 3? Do you remember? Yes. So it's pi minus pi over 6, which is, what is 5? Is 5 pi over 6, right? Five pi over 6. Because sine of 5 pi over 6 is 1/2. Cosine of 5 pi over 6 is minus root 3/2. And then when you divide, you get minus root 3 over 3. Now, this is the answer between 0 and 2 pi. That is the first part. For the second part, what are other? Because there are infinitely many other solutions. What are the other solutions? You just add k pi. So or in general, for part 2, theta is k pi plus 5 pi over 6 for any integer k. So that is part 1. That is part 2. Now let's do the same thing for 10a. So it says cos square theta is 4 over 5. So that means cosine theta is equal to 2, or I can just say square root of plus minus the square root of 4 over 5, right? Now let's first look at plus. If cosine theta is just plus 4 over 5, and we have, in the question, we have theta is between 0 and 2 pi. Okay. If cosine theta is square root of 4 over 5, then can you use your calculator to find theta? So theta is cos inverse of square root of 4 over 5. So what is theta? Can you, I don't have calculator. Can you use calculator to tell me theta? What? That is in terms of degree, right? Okay, so this is 26 degrees. What is it? Let me see.
It's 26. Why'd you put 2 brackets?
Just to make sure everything is going to be good. This is 26 degrees, right? About 26 degrees. How about cosine theta equal to minus? So that means theta is 180 degrees minus 26, right? Which is something about 180 minus 26 is 154. These are the answers for theta between 0 and 2 pi. Oh, between 0 and 2 pi, but there are more answers between 0 and 2 pi. These are the two answers between 0 and pi. But if you want between 0 and 2 pi, there is another one here. So theta equal to 360 minus 26. And another one here. Maybe I write the other solution with another color. So one answer is 26. the other one is and here the other answer is so these are 4 answers for this equation for theta between 0 and 2 pi. So for cos theta is equal to positive square root 4/5, there are 2 answers. For negative, also there are 2 answers. These are the 2 answers, right?
Why does according to the large AD?
Because the cosine of 180 minus 26 is minus cosine of 26. So remember cosine of pi minus theta. Let me write here this equation just to recall. So cosine of pi minus theta is equal to minus cos theta, right? Because x is negative in the second quadrant. And cosine of pi plus theta is equal again minus cos theta. So there are lots of things here you have to think about and digest. Okay. So once you've finished the assignment, and I really want you to go over the other questions too. You don't have to submit, but it's good. You should be able to do this, okay? Yes. This 2b, very good. I will do that. So secant minus 1 divided by tangent equal to tangent divided by secant plus 1. So we want to prove this. I mean, the shortcut here is you can cross multiply. It becomes very easy. I mean, I can do it in 2 ways. I mean, many ways actually. But the shortest way is to cross multiply. So you have to prove that tangent square theta equal to secant theta minus 1 times secant theta plus 1, right? Now I look at this identity. So the right-hand side, now the right-hand side is what? Secant theta minus 1 times secant theta plus 1. That is equal to secant theta square minus 1, right? But we know that this is just tangent square. And this is the left-hand side. So recall that 1 plus tangent square theta is 1 plus sine square divided by cosine square is equal to cosine square plus sine square divided by cosine square is equal to 1 over cosine square, which is secant square. So the bottom line is 1 plus tangent square is secant square. That means secant square minus 1 is tangent square, right? So 1 plus tangent square is secant square. Therefore, secant square minus 1 is tangent square. Is that clear?
Can we solve it?
We can also do that. Yeah.
Aren't you like not allowed
So we
to?
view to
Pardon me?
You're not allowed to work on it. You can't like move things around.
No, you can't. That's fine. You can't do this. Or let's do without multiplying, without cross multiplying. So let's say that I begin here with the right-hand side. So tangent theta divided by secant plus 1. So another way is, let me just copy this. So the right-hand side is tangent theta over. So I try to simplify the right-hand side. Let's see what I get. So it's equal to sine theta over cosine theta divided by 1 plus 1 over cosine theta. But this is equal to sine theta over cosine theta plus 1, right? Make sense? Okay, so cosine theta plus 1, we have sine theta. Okay, now let's go to the left-hand side. Let's see what is left-hand side. The left-hand side is secant theta minus 1 divided by tangent theta is equal to 1 over cosine theta minus 1 divided by sine theta over cos theta. But this would be equal to, you have 1 minus cos theta divided by sine theta. Okay, now we want to show that these two are equal. So what you can do is the following. You can Okay, so if you multiply this, I mean, you can either work on the right-hand side or the left-hand side, but let's multiply the top and bottom with cosine theta. So that would be equal to 1 minus cosine, oh, sorry. If you multiply by cosine, you get cosine theta minus cosine square theta divided by sine theta times cos theta. So I can write this as just wait.
This, multiply what plus cosine. Plus cosine.
Let's do that. Maybe that would be better. Yes, so let's multiply by 1 plus cosine theta. Okay, so let's do this. So what you get is, on the top, you have 1 minus cosine square theta. At the bottom, you have sine theta times 1 plus cosine theta. Yes, now this works. So this is equal to sine square theta divided by sine theta times 1 plus cosine theta, which is equal to sine theta over 1 plus cosine theta. And that is equal to the right hand side. Good suggestion. I like that. Okay. You could also maybe work on the left-hand side. If you multiply, sorry, the right-hand side, you multiply it by 1 minus cosine theta, you get the left-hand side. I mean, these things you can do several in different ways. Okay. Is that clear? You see, at the end, we get the similar thing. Okay, good question. Is that clear, Maggie?
Like 12 and 15.
I mean, maybe another way, let's do the same thing. Let me tell you why cross multiplying is okay. Let me explain it to you. So you have you want to prove this. Secant theta minus 1 over tangent theta equal to tangent theta over okay. So let's begin with the left-hand side. So left-hand side, another way. I just do it another way. So the left-hand side is secant theta minus 1 over tangent theta. So what you can do here is you can multiply this by secant theta plus 1. I mean, both top and bottom. Because if you multiply by the same thing, it doesn't change anything, right? And then multiply again by that's right. So these are just one. These two blue things are just one. But if you multiply this, you get on the top, you get secant square theta minus 1 divided by secant theta plus 1 times and then tangent theta. I mean, even you don't need to multiply by this. Okay, so now this is equal to, on the top, you have secant. What is secant square minus 1? Secant square minus 1 is tangent square, right? Divided by secant theta plus 1 times tangent theta. And then if you tangent the square over tangent, it's just tangent theta over secant theta plus 1. And that is just equal to the right-hand side. So it's enough to multiply the left-hand side by secant theta plus 1 and divide it by secant theta plus 1. No, I multiplied by 1. I just multiplied by 1. Because if you multiply by 1, it doesn't change anything, right? Do you see? Secant theta plus 1 over secant theta plus 1 is just 1, right? This whole thing is 1. So if you multiply something by 1, it doesn't change anything, right? Okay. Is that clear? Any question? Any other questions? Okay, so I want you to finish your assignment. And as I said, once you finish your assignment, it would be good for your own to these test questions. And then we can have the trigonometry test. Can we do it on Thursday? No, Friday. This Friday. Sounds good? Friday.
Okay.
Monday?
We've been having all of our tests on Monday.
Okay, Monday.
You get